Welcome to today's session where I'm going to cover how you can accelerate SaaS development with SaaS Builder Toolkit for AWS. So we're going to do a architecture walkthrough of the SaaS Builder Toolkit followed by a quick demo. My name is Pranjit Biswas and I'm a solution architect here at AWS. In SaaS, we often say that there is no one size fits all. Your existing code base serves as the foundation for your SaaS journey. To transform your application into a successful SaaS offering, you will need to incorporate various components and services tailored to your specific requirements, such as multi-tenancy, scalability, monitoring, billing, and security. The good news is that you do not have to start from scratch. By leveraging reusable components, best practices, and the expertise of industry professionals, you can accelerate your SaaS development and build a solution that meets your unique business needs. This approach positions you for success in the ever-evolving SaaS market. When building software solutions, architects and developers frequently encounter challenges related to scalability, performance, security, and maintainability. Developing software as a service solutions introduces unique architectural challenges that must be addressed to ensure a successful and efficient multi-tenant environment. On the identity and management side, where multiple tenants share the same application instance, effective identity management is critical. Architects must implement robust authentication and authorization mechanisms to ensure that each tenant's data is isolated and accessible only to authorized users within that tenant. On the observability side, SaaS architects must establish comprehensive monitoring and logging strategies to collect and analyze application telemetry data effectively. This also enables proactive identification and resolution of issues, ensuring high availability and performance. In a multi-tenant environment, the resource utilization patterns of one tenant can impact the performance and experience of other tenants, known as the noisy neighbor problem. To prevent a single tenant from monopolizing shared resources and degrading the performance of others, architects must implement effective resource isolation and throttling mechanisms. To prevent unauthorized access to tenant data and maintain compliance with relevant regulations, architects must also implement robust tenant isolation mechanisms. This includes database partitioning, secure data encryption, and strict access controls. SaaS applications also often need to support different service tiers or pricing plans, each with varying level of features, resources, and performance characteristics. Architects must design flexible tiering strategies to accommodate these variations while maintaining overall system efficiency. Architects must also optimize the architecture to minimize the cost per tenant while maintaining the desired level of performance and scalability. This involves implementing cost-effective scaling strategies, resource sharing mechanisms, and leveraging cloud service providers' pricing models effectively. Understanding the best practices and addressing the previous architectural challenges is crucial for efficient development and deployment. For example, when building an identity and onboarding workflow, typically we conduct the necessary research, which is our discovery phase, followed by the design and the development phase. This is a typical SDLC life cycle, right? Now, consider the fact that once we have developed the code to create tenant identities and various services to onboard the tenants within the identity and onboarding workflow, and once deployed to production, we might discover that some onboarding services are not directly related to tenancy and would benefit from being separated into their own components. You would then rebuild and redeploy these services accordingly. Similarly, for identity, you might realize that the identity generated by the identity provider should include tenant context, This enriched identity would then be used within your architecture to improve efficiency. Following these insights, you would implement and deploy the necessary changes to production, continuously repeating this cycle of improvement. What if you could accelerate this cycle and start with a solid foundational implementation that incorporates SaaS best practices? Hence, we happily introduce the SaaS Builder Toolkit, or SBT, which is developed by our AWS SaaS Factory community. It is an open source collection of modular components and best practices designed to streamline SaaS development on AWS. Our goal is to enable customization, accelerate projects, and reduce time to value for organizations embarking on their SaaS journey. It offers a library of reusable common components that serve as foundational building blocks for any SaaS solution. These components are abstracted and encapsulated, allowing you to focus on delivering value to your customers without reinventing the wheel for every project. SBT encapsulates industry best practices for building SaaS solutions on AWS. By leveraging SBT, you can quickly integrate these proven practices into your solution, ensuring a solid foundation for your SaaS offering. It also aims to accelerate your time to market. By streamlining the development process and providing a robust framework, it enables you to launch your SaaS product faster, allowing you to capitalize on opportunities and stay ahead of the competition. Recognizing the importance of integrating with popular independent software vendors, SBT includes pre-built integrations with leading ISV offerings. This enables seamless connection and utilization of powerful tools within your SaaS solution. It leverages the flexibility and extensibility of AWS Cloud Development Kit, or CDK constructs. By utilizing CDK, you can customize and extend the solution to meet your unique requirements, ensuring your SaaS offering is tailored to your specific needs. When it comes to building a robust and scalable multi-tenant SaaS solution, the architecture plays a crucial role. At AWS, we have observed a recurring pattern among successful SaaS implementations: the separation of concerns into two distinct planes, the application plane and the control plane. Let's start with the application plane on the right. This is where the core functionality of your SaaS offering resides. The business logic, microservices, and unique value proposition that you deliver to your customers or tenants. This is your IP. This is the heart of your application, where you pour your innovation and creativity to solve real-world problems. Now let's shift our focus to the control plane, shown on the left-hand side of the diagram. This plane is responsible for managing and operating your tenants through a unified experience. It is a foundational layer that enables the multi-tenant SaaS model, providing a collection of shared services that orchestrate the multi-tenant experience for your application. Within the control plane, you will find an administration application, typically a web interface that allows you to manage your multi-tenant environment. This application leverages various shared services such as identity and onboarding, tenant registration, tenant management, tenant provisioning, user management, billing, and metrics. The SaaS Builder Toolkit, or SBT, is designed to encapsulate the responsibilities and functionalities of both the application plane and the control plane, providing you with a comprehensive toolkit for building your multi-tenant SaaS application. On the left-hand side, you will see the control plane components of SBT, represented by the blue boxes. These coarse-grained chunks of functionality, such as identity and onboarding, tenant management, billing, and metrics, are the building blocks you will leverage to manage and operate your tenants. On the application plane side, SBT is largely unopinionated about your application specifics. As long as your application can subscribe to the messages sent by the control plane and respond according to the contracts defined in SBT, it will be compatible. Along the top of the diagram, you will see point solutions. which are reusable components that you can integrate directly into your code base, deploy as standalone services, or provision as infrastructure constructs using AWS CDK. Examples include the token vending machine for tenant-aware authentication and the CloudWatch Grafana metrics dashboard for tenant-isolated monitoring and observability. At the heart of SBT lies Amazon Event Bridge, a serverless event bus for building event-driven applications at scale. SBT provides helpers in each plane to publish and subscribe to messages relevant to SaaS workflows, enabling seamless communication and integration between the two planes of your SaaS application. With SBT, you have a powerful toolkit at your disposal designed to accelerate your journey towards building a successful multi-tenant SaaS solution on AWS. Moving on, now we will delve deeper into the control plane architecture. Please take a note of the yellow colored section which denotes the control plane. On the left, we have our SaaS administrators interacting with an external cloud which is out of the box and not part of our system. Within the yellow box, we have developed an IAuth interface that defines how to secure this API. While we offer Cognito implementation, the interface is designed to be flexible, allowing for alternative implementations such as Auth0, Okta, or any other authentication provider per se. A pluggable version of this authenticator or authentication service can be integrated into our system, providing versatility for various implementations. To illustrate this concept, I'll share some code examples shortly in our demo. In terms of deployment, the control plane side includes an API gateway that handles essential boilerplate functionalities needed for all SaaS applications. This includes user management for tenant users, SaaS application users, and SaaS admin users, as well as tenant management. Tenant management encompasses creating a tenant in the system, tracking its lifecycle from creation to deletion, and opting into other blue box services such as billing. For billing integration or connecting with external billing providers, these actions are part of the tenant creation lifecycle. We maintain flexibility in tracking these activities, and a NoSQL database like DynamoDB is ideal for storing tenant information due to its adaptability to varying data shapes. On the right-hand side, we utilize Event Bridge to facilitate event flows between the two planes. Numerous lifecycle events occur when a tenant goes online. We subscribe to some of these events on both application plane and the control plane to perform necessary actions such as setting up billing. The event-driven programming model of Event Bridge allows us to surface these events and implement custom actions as needed. The extensibility and decoupling are key advantages of using Event Bridge. Moving on, here we'll be discussing the application plane side, which offers various utilities. A crucial aspect is our ability to tune into events as receivers. For instance, consider a provisioning and deprovisioning job. When a provision event is received, we utilize a utility that integrates with code build, passing essential information such as tenant name, plan, tier, and admin email. This information is packaged and transmitted via Event Bridge. In the provisioning job, you can specify necessary tenant variables such as the tier to determine if a separate cluster or namespace needs to be created. Our objective is to provide maximum flexibility without making assumptions about your application and tenant requirements. The tenant registration API captures detailed information which is stored in a details table for later access. These utilities, which wrap around code build, function similarly to a cloud-based bash shell. You provide a script for onboarding your tenant, which is then wrapped in code build. This process is managed by step functions to handle timeouts and exit cases. It interacts with Event Bridge, extracts the specified variables and makes them available for the control plane or other listeners. Code build can deploy tenant infrastructure on your behalf, and for deprovisioning, it can delete infrastructure by executing a CloudFormation delete command. Now here we are discussing about the billing architecture components. Our goal is to support multiple billing providers, allowing independent software vendors or ISVs and customers to choose their preferred provider and integrate it seamlessly. We manage the boilerplate tasks associated with adding new billing providers. The core functions like creating a customer, updating a customer, and deleting a customer are closely tied to the specified billing provider you are working with. When a billing provider like Stripe or ChargeBee wants to extend SaaS Builder Toolkit or SBT, they provide the necessary functionality and we integrate it. For instance, when provisioning a new tenant, we trigger a create customer lambda function if billing is enabled. This function registers the tenant with the billing provider, for example Stripe. Additionally, we also offer optional helper functions. On the right hand side, if you notice, we have Kinesis data firehose, which ingests data and feeds it into a pipeline. This pipeline aggregates the data and sends it to the billing provider. The usage functionality is also specific to the billing provider and maintained by them. In your SaaS app, you simply identify the endpoint for the Kinesis data firehose and send metrics to it. The entire process happens seamlessly without the overhead of manual data ingestion and aggregation. Now, we're going to do a quick demo of the SaaS Builder Toolkit and how quickly you can use those components within the control plane and the application plane to build your SaaS application. So moving on to the demo part, I'm following the SaaS Builder Toolkit Workshop Studio, but for your benefit, okay, you can either use the GitHub repo, it's the same instructions, or the Workshop Studio. And for the interest of time, I've already set up my environment, so I've already completed the lab 0. In this demo, I'm going to cover the deployment of control plane and deployment of application plane and a quick test to show how they talk to each other and how you can onboard a tenant, right? Now, moving on to the AWS console, as I mentioned before, SaaS Builder Toolkit is built on top of CDK. So to illustrate its use, we will first initialize a blank CDK application. So to do that, we're going to move to Cloud 9. And as I've already set it up and completed the lab 0, once you move to the Cloud 9, you would already see there's an environment provision for you, which is SBT Workshop. And we're going to open the IDE. And then I'm going to scroll up. And then what we're going to do is we're going to create a new directory called SBT demo directory. We're going to move to that demo directory, and then we're going to initiate a blank CDK project using TypeScript. I'm going to expand this. Now, the next step would be to install the SBT components. So to do that, from the SBT demo directory, we're going to run the npm install command. So we'll wait for this project to be completed. And now that it's completed, I'm going to clear the screen. And then we're going to run npm install command. What it's going to do is it's going to install the SBT components, right? Now, after the SBT components are installed, we're going to create a new control plane based on the SBT. So for doing that, we're going to expand the library folder, and then within that there is already a TypeScript file SBT demostack.ds. We're going to delete this TypeScript file, and we're going to create a new file, and we will name it control plane. I'm going to expand that, and then we're going to copy the entire code block that's there in the GitHub as well as the Workshop Studio. Do note, please ensure that you use a valid email address to receive the tenant admin user password. So I'm going to give my email address so that I am going to receive the tenant admin user. And then notice here, if we scroll up, what we're doing over here is we're going to create a new CDK stack called control plane stack. In that stack, we are creating a single control plane construct, right? Which we have imported from the SBT-AWS package. And this control plane construct is created with a number of different properties, most of which are used to configure the event bridge communication between the control plane and the application plane. Another important point out here is the pluggability of this approach. Notice here we are creating an auth component, right? And then we have named it as cognito auth. This component implements the iAuth interface defined in the SBT code package that we have covered in the architecture walkthrough. We are currently using cognito implementation of iAuth, but we could technically implement that interface with any other identity provider, Auth0, Okta, to name a few. Now let's build and deploy this component. So to do that, I'm going to save this file. But before we run the deploy and the build command, we have to modify one more file, which is the sbt-demo.ts, which is inside the bin directory. So I'm going to expand that, and we're going to open this, remove all the contents from here, and then we're going to copy paste the one that is there. Notice here there are a couple of constructs, okay, that we have commented out, which is mostly around the application plane stack. Application plane, okay, we'll come back in the second part of this, and we're going to uncomment and then deploy the application plane. So for the time being, we are just deploying the control plane, right? Now what we're going to do is we're going to save this file, and then from the SBT demo directory, we're going to run npm run build. And then once that is completed, we're going to run cdk bootstrap. And then the last command is to deploy the control plane stack. So once this is completed, it's going to create the cloud formation. I'm going to pause the video. So the CDK bootstrap is completed. After completion of the CDK bootstrap, we're going to deploy the control plane stack. So we're going to run CDK deploy control plane stack, and then this will kick off the synthesis of your CDK application. It's going to deploy the cloud formation. Right behind the scenes, a lot is getting created. This constructs not only stands up the surface of our control plane API using a new API gateway component, it also deploys several services such as AWS Lambda functions used for tenant provisioning and management. Once done, we now have the left-hand side of our architectural diagram deployed, and we did it with a single construct. It deployed not only the API surface of our control plane, but also wired it up with the event bridge. Next, we will start deploying the application plane and connect it to the same event bridge bus so that we can act upon those control plane messages. But before the application plane, we will take a look at the control plane's artifacts, what's been created. So we'll wait for this to complete, and then we will move to the AWS console. So I'm going to pause the video. Once this is completed, we'll resume back. If you see, the cloud formation template has kicked off, and it has started deploying the control plane stack within a single construct, right? Now if you see, our deployment of the control plane stack is completed successfully. So what we're going to do is we're going to move to the AWS console, and then we're going to first check Amazon Cognito, where we will see there is a SaaS provider administrator that will get provision. This is the admin who is managing this SaaS service. He or she may have the authority to control whole service, and you should have received a temporary credential to log in as a tenant admin, which we would need when we do the testing of both the control plane and the application plane later in this demo, right? Now moving on, if we move to the DynamoDB and then click on tables, we would see there is a table that has been created for the control plane stack, and inside that there is tenant details, tenant ID and all that. And then if we select this is the table where you would have all the tenant related information like tenant ID, tiering, all that will get stored once we deploy a tenant. The lambdas that gets attached to each and every API. So now let's move on to the API gateway console, where you can check there are APIs about different tenant methods like get, post, put, delete, and then with each and every API there is a AWS lambda that gets. Now let's do the application plane deployment. As mentioned before, SBT is unopinionated about the application in which it's deployed. As a result, you expect to create the application plane construct as just another part of the CDK constructs that you would use to define your application. Although entirely optional, SBT also includes a utility that lets you define and run arbitrary jobs upon receipt of a control plane message called a job runner. Provisioning and deprovisioning scripts are fed to the job runner as parameters, and internally the job runner launches the AWS Code Build project, which is wrapped inside the AWS step function to execute the bash scripts. The job runner also lets you specify what input variables to feed to the scripts, along with what output variables you expect them to return. Note that in this version of SBT, job runners are created by the code app plane. Now, if we are going back to the IDE, let's create a new folder under lib and name the file as appplane.ts. We're going to copy the code block that's there in the GitHub repo or the Workshop Studio and paste it here. We're going to save that appplane file. Now this looks like a lot of code, but it's still a single construct with a lot of configuration sent to it. Here what we have done is we have defined the application plane, right? And then now we are going to open the sbt demo.ts file where we have uncommented we're going to uncomment the application plane stack that I've showed, like, which was commented initially, right, over here. But before we do that, let's quickly do a rundown of this application plane file. Right here we are defining the application plane stack, and then we're going to echo the tenant ID and the tier, and then once that's in input, it's going to create a CloudFormation stack, is going to import that information, and then it's going to create the application plane stack, and then once the provisioning is successful, it's going to feed back some of the tenant related information, right, like tenant S3 bucket, tenant config, status, all that back to the event bridge for the control plane to spit out, right? That's kind of in a gist, okay, we're doing within this file. Now we're going to come back to this sbt demo.ts, and then we are going to uncomment the commented line. And I'm going to save this. Once done, let's deploy the solution again. So for doing that, we're going to run npm run build, and then we're going to deploy both the stack together now, control plane stack and application plane stack. Once deployed, we will run a few tests to see our basic control plane and application plane in action. So I'm going to pause the video and then come back once this deployment is completed. Now if you notice here, the deployment is completed. What we're going to do is we're going to create a test script and test the application plane and the control plane. For this test, we are actually going to onboard a tenant and it's going to create a S3 bucket for that specific tenant. But if you want to do further, okay, you can move ahead with the ECS SaaS reference architecture built on SBT and the marketplace integration as I mentioned before. So to run the test, we need to create a test script. So I'm going to create a sbt-test.sh under sbt demo home directory. And I'm going to open that and copy the script. And if you remember, we actually used an email address, right? Which actually you must have received a temporary admin credential during the deployment of the control plane. So we are going to open that email that you have received and then copy those credentials to be able to log into that account. So for doing that, you need to insert the password from that email over here, insert password here. So I'm going to do that for my email. So let me paste it over here. And then I'm going to save this. If you look here, what we're actually doing here is at the bottom, this script will onboard a new tenant and then it actually retrieves its details, right? What is the S3 bucket, the tenant details and all that. And this script uses the JQ JSON processor. So to run this script, we're going to do sh So we're going to run this command. Now that if you see, it's going to onboard a new tenant, right? So, and if you see here, the tenant is created and is actually retrieving the tenant related information after the onboarding with the tenant ID, the tiering, right, the email address and all that information, right? Now let's move on to the AWS console and see what has happened over there. So if you go to DynamoDB console and we're going to click on tables, we're going to open these tables and explore table items. If you see, we just have onboarded this tenant, right? This is the tenant ID, the email, active, and then if you see, it's still showing in progress because it's still onboarding that, right? Okay, but most of the details have already been. And if you see over here, these are all the attributes of the tenant, right? Now recall that we have deployed a job runner with our application plane, and it's just a wrapper around the AWS step function that runs our provisioning script via code build. Now let's take a look into the step function. And ensure that you are running in the same region that you have deployed to. So if you see over here, there is a state machine over here, and then there is an execution which has succeeded, right? And feel free to examine the execution. Once finished, it's going to return the results back to the event bridge, right? It's going to notify the event bridge over here and close the loop with the control plane once the tenant deployment is completed. With that, my demo is completed. I hope it was useful to all of you. Before we wrap up, I wanted to share some of the resources for you to get started. The first QR code is a YouTube video of introducing the SaaS Builder Toolkit by our SaaS Factory team. The second QR code is the link to the GitHub repo of the SaaS Builder Toolkit for you as a developer to get started. The third link is the Workshop Studio hands-on for the SaaS Builder Toolkit AWS. With that, we are at the end of our session today. Thank you for watching this video and happy building SaaS solutions on AWS.